Picture a photograph taken in 1952. Long before the first satellite ever left the ground, before any nation had the power to put a machine into orbit, a camera pointed at the night sky captured something that should not have been there. A bright point of light sitting quietly among the stars. 30 minutes later, a second photograph of the exact same patch of sky. The light is gone. No trace, no explanation, nothing in its place. For decades, this photograph sat in an archive, one of hundreds of thousands of glass plates gathering dust in an observatory in California. Nobody thought much of it. Then a small team of scientists went looking through the archive with a very specific question in mind, and what they found has reopened one of the oldest debates in human history. Are we really alone up there? And if we are not, has something been watching us for far longer than we ever imagined? I want to walk you through this story carefully, because it is easy to get swept up in the more sensational headlines. But underneath the headlines is a genuinely strange scientific puzzle, one that has divided professional astronomers, produced dueling research papers, and dragged old Cold War folklore about UFOs and nuclear weapons back into the light. By the end, you can decide for yourself whether this is the strongest evidence yet that we have company in orbit, or a fascinating case of scientists chasing shadows in old photographs. Let's start with why anyone would bother digging through 70-year-old star maps in the first place. Humans have been seeing strange things in the sky for as long as we have been looking up. Long before airplanes, long before rockets, people recorded lights, shapes, and objects moving overhead that they could not explain. Most of the time, we now know exactly what these people were seeing. A comet was mistaken for an omen. A meteor shower became a battle between spirits. Ball lightning, a genuinely rare and strange atmospheric phenomenon, was reported as fireballs sent by angry gods. As our understanding of physics and the atmosphere improved, one mystery after another got quietly solved. But a stubborn handful of old accounts never fit neatly into any of the boxes we created for them. In the mid-1500s, a German city reported that dozens of witnesses watched glowing shapes described as crosses, tubes, and spheres appear to clash with one another in the sky above the rooftops for close to an hour before falling to earth trailing smoke. The account was written down at the time, illustrated and widely distributed as a printed news sheet, the 16th century equivalent of breaking news. Read today, it sounds eerily like a modern UFO encounter. Multiple objects, erratic movement, a violent aerial event witnessed by an entire town. Historians and skeptics have offered plenty of down-to-earth explanations over the years. A rare weather phenomenon, called a sundog, where ice crystals in the atmosphere bend sunlight into strange shapes. An early and dramatic religious pamphlet designed to scare people into repentance. Possibly a mix of both. The trouble is, there is no way to actually test any of these theories. Nobody kept a fragment of the object. Nobody has a second independent report from a nearby town to compare notes with. All we have is one account, written by one author, describing what a crowd claimed to see nearly 500 years ago. As fascinating as it simply is not the kind of evidence a scientist can build a case on. This is the problem with almost all historical UFO reports, and honestly, with a lot of modern ones too. A single eyewitness, dare un genuine account, however sincere, however detailed, is not data in the scientific sense. It cannot be measured, repeated, or independently checked. You need something more rigorous. You need instruments, records, and ideally thousands of data points rather than one dramatic story. It is worth pointing out that this problem has not gone away just because we now live in an age of satellites and smartphones. It has simply changed shape. In recent years, governments have started releasing genuine, verified military sensor footage of objects that trained pilots could not identify, tracked by radar and infrared cameras rather than eyewitness memory alone. That footage is a real step forward, because at least now there are instruments involved rather than just a person's word after the fact. But even the best modern sensor footage tends to be short, low resolution, and open to more than one interpretation, whether that turns out to be a distant aircraft catching the light. Strangely, a weather balloon, or a genuine sensor artifact. What has always been missing from this entire field is scale. Not one strange video, not one dramatic photograph, but a large, structured, statistically testable body of evidence, collected under consistent conditions over a long stretch of time, that other scientists can independently check. Which brings us to a Swedish astronomer named Beatrice Villaroel, and a research project with an almost comically long name, the Vanishing and Appearing Sources During a Century of Observations project, or VASCO for short. Villaroel did not set out to hunt for UFOs. Her original goal was far more mundane in the best sense of the word. She wanted to find stars that had simply vanished. Old star catalogs from the 1950s list the positions of enormous numbers of stars. If you compare those old catalogs against modern surveys of the same patches of sky, you would expect almost every star to still be there. Stars do not usually disappear on a human timescale, so when a star that was clearly documented decades ago is simply missing from a modern high-resolution survey that is worth investigating, it could point to an extremely rare and violent stellar event, something astronomers would love to understand better. To do this work, Villarroel's team turned to a specific archive: photographic plates taken at the Palomar Observatory, one of the great telescopes of the 20th century, which began its major sky survey work in the late 1940s. These glass plates painstakingly exposed to starlight for minutes at a time, and then developed like old-fashioned photographic film, form one of the most complete records we have of the sky before the space age began. Palomar's survey ran from roughly 1949 through 1957, right up to the eve of Sputnik's launch. That timing matters enormously, and we will come back to it. Digitizing and searching through this kind of archive is not a small task. We are talking about tens of thousands of individual glass plates, each one covering a wide patch of sky and containing, on average, well over 100 faint transient-like features, once you account for genuine noise and instrumental artifacts. To make this manageable, the Vasco project eventually recruited volunteers through a citizen science platform, ordinary members of the public trained to compare pairs of digitized plate images and flag anything that looked like it appeared in one exposure and vanished in the next. It is a slow, painstaking process, closer to spotting the differences between two nearly identical pictures than anything glamorous, but it is exactly the kind of large-scale pattern matching that makes this project fundamentally different from a single eyewitness staring up at the sky for a few seconds. Comparing these old plates against modern digital surveys, the team did find a modest number of genuinely vanished stars, somewhere around 100 candidates worth further study. Interesting in its own right. But while sifting through the plates, something else caught their attention, something that had nothing to do with stars disappearing over decades. On a handful of individual plates, they found points of light that appeared in one exposure and were completely gone from a second exposure of the exact same spot, taken as little as 30 minutes later. Astronomers have a fairly boring technical name for these blips: transients, and ordinarily, transients are not mysterious at all. A defect in the photographic emulsion, a speck of dust on the plate, a cosmic ray hitting the detector, a fast-moving asteroid catching the light for a moment. Palomar's own archive contains an enormous number of transients, and the overwhelming majority have perfectly mundane explanations. What made Villarroel pause was a specific batch where 9 separate points of light appeared together on one plate and were simply absent 30 minutes later, and then absent again 6 days after that, when the same patch of sky was re-imaged. In a 2021 paper, she systematically worked through the obvious suspects: distant flaring galaxies, fast asteroids passing through the frame, passing aircraft, even gamma-ray bursts, one of the most energetic events in the universe. One by one, the data ruled each of them out. She also seriously considered a much more grounded explanation: radioactive contamination of the photographic plates themselves. If a plate was accidentally exposed to radiation, perhaps from fallout drifting from a nearby nuclear weapons test, it could produce exactly this kind of false bright spot. It is a genuinely clever hypothesis and worth taking seriously, especially given that Palomar sits a few hundred miles from the Nevada desert, where the United States conducted a large number of its early atomic tests. But when Villarroel checked the specific dates against the historical test record, there was no atmospheric nuclear test scheduled anywhere close to those particular exposures. That explanation, at least for this specific batch, did not hold up. There was one more obvious candidate to rule out, and it is almost funny in hindsight. Could these be glints of sunlight bouncing off a satellite? We are all used to this idea today. Anyone who has watched the sky at dusk has catching sunlight even though the ground below is already dark. But there is a problem with that explanation for these particular plates. The first artificial satellite in human history, Sputnik, was not launched until October 1957. The plates showing these 9 mystery points of light were exposed in 1950. Whatever these objects were, they were not satellites because at that point in history, satellites simply did not exist. That single fact is really the seed of this entire story. If these transients are real physical objects reflecting sunlight rather than plate defects or statistical noise, then they were up there in orbit before humanity had the technology to put anything into orbit ourselves. Villarroel's team spent the following years quietly expanding the search, and in October 2025, they published 2 major new papers that took this investigation to a completely different scale. Instead of 9 mysterious points of light on a handful of plates, they had now combed through nearly a decade of Palomar's archive, from 1949 to 1957, and cataloged more than 100,000 transient candidates. Obviously, the overwhelming majority of 100,000 blips are going to be mundane. Nobody is claiming that all of them are alien spacecraft. The real question was whether, buried inside that huge pile of noise, There was a genuine, statistically detectable population of objects that behaved differently from ordinary defects and artifacts. To test this, the team used two main approaches, and both of them are, frankly, quite elegant. The first approach uses something every school student learns about. The Earth casts a shadow into space, directly opposite the Sun. If you plotted where in the sky transients were being detected, and those transients were caused by random plate damage or chemical defects, you would expect them to be scattered evenly across the whole sky, with no relationship to the Earth's shadow whatsoever. A scratch on a photographic plate does not care where the Sun is, but if the transients were caused by sunlight, corresponding to the Earth's shadow compared to everywhere else. In their most detailed follow-up study, they described the shadow effect as extremely statistically significant, describing it as a deficit strong enough that they felt confident ruling out simple plate damage as the explanation for at least a subset of the transients, several hundred out of the full sample, that appeared to genuinely track the geometry of the Earth blocking sunlight from a particular direction. Think about what this test is actually doing, because it is a clever piece of reasoning. A defect on a photographic plate, a scratch, a chemical smudge, a speck of dust that got baked into the emulsion, has absolutely no way of knowing where the Earth's shadow happens to fall on a given night. It should be scattered essentially at random across every plate, regardless of geometry. An object physically orbiting the Earth, on the other hand, is completely at the mercy of that geometry. It can only reflect sunlight back toward a camera on the ground if the sun can actually reach it in the first place. Ask that same question of 100,000 data points spread across nearly a decade of nightly observations, and either the pattern lines up with the shadow or it does not. That is the sort of test that is very hard to fake by accident, which is exactly why both sides of this scientific argument have ended up fighting so hard over whether the underlying dataset was clean enough to trust in the first place. The second approach was more sociological than astronomical, and honestly the part of this story that raises the most eyebrows. The team cross-referenced the dates of these transient detections against two completely separate historical datasets, recorded UFO sighting reports made by ordinary members of the public, and the official historical record of above-ground nuclear weapons tests. Here is where things get genuinely strange. According to the team's analysis, on days when more UFO sightings were reported by the public, the Palomar plates also tended to show a higher number of transients, an increase they measured at somewhere around 8.5% for every additional public sighting logged. Think about what that would require if taken at face value. People on the ground, with no telescopes and no idea that a specific astronomical plate was even being exposed that night, were reporting unusual lights in the sky at roughly the same time that unexplained points of light were showing up in professional astronomical photographs. Neither group had any way of coordinating with the other. Then there is the nuclear connection, which is the part of this story that has genuinely puzzled even sympathetic scientists. The team found that transient detections rose sharply around the dates of atmospheric nuclear weapons tests, with the biggest spike somewhere in the range of 45% above baseline in earlier work, showing up specifically on the day immediately following a detonation. On the surface, this sounds backwards. If these transients really are unidentified craft, why would they show up more often right after humanity set off a nuclear bomb? But if you have spent any time around UFO research, this pattern will sound familiar, because it echoes decades of anecdotal claims connecting unidentified objects with nuclear weapons facilities specifically. The most famous of these anecdotes took place in October 2010 at Francis E. Warren Air Force Base in Wyoming, home at the time to 50 Minuteman III nuclear missiles on alert status. According to multiple military personnel who later spoke about the incident, a large cigar-shaped object was seen hovering near the base over the course of that week. Around the same time, in an event that is not disputed and is a matter of official record, all 50 of the base's nuclear missiles simultaneously dropped offline, a complete and unprecedented failure of the entire flight's launch control system. The Air Force's official explanation involved a hardware fault in the underground cabling. It never officially linked the failure to any object in the sky. But the timing and the sheer scale of the outage, 50 missiles going dark at once with no prior incident of that magnitude on record, is exactly the kind of detail that keeps this story alive among researchers who study military encounters with unidentified objects. What makes the Wyoming case stand out from most UFO folklore is how many separate, named military witnesses eventually went on record describing it, years after the fact, once retired from active duty and no longer bound by the same career pressures to stay quiet. Several of them described the object in strikingly similar terms, a large, silent cylindrical shape that hovered rather than flew in any conventional sense, before departing abruptly. None of them claimed to know what it was. What they consistently insisted on was the timing, that the object was there in the days leading up to an outage that the Air Force itself has never fully explained to public satisfaction, despite pointing to a faulty circuit card as the official cause. An even more dramatic, though far less independently verified, story comes out of Soviet military folklore from the early 1980s. Accounts describe an object hovering above a Soviet nuclear missile base for several hours, during which control panels reportedly indicated that missiles had entered a launch sequence on their own, with officers unable to override the process until the object finally departed. This account is much harder to verify through open records than the Wyoming incident, and should be treated with real caution, but it belongs to the same broader body of Cold War-era testimony, suggesting that whatever these objects are, if they exist at all, seem to take a particular interest in humanity's most destructive weapons. Seeing a statistical echo of that same pattern, nuclear test days lining up with a spike in unexplained transients on decades-old astronomical plates, is precisely why VROL's papers generated so much attention when they were published. For the first time, someone was not just retelling an old story, they were pointing at a dataset and a p-value. Now, before you get too carried away, I need to walk you through the other side of this story because the scientific community's response has been sharply divided, and the criticism is substantial. When Villarreal's team tried to post an early version of this research to Arxiv, the widely used platform where scientists share papers ahead of formal peer review, the moderators declined to list it. Their stated reasoning was that the work did not meet the bar for original, substantive scholarly research. That is a real setback, and it is worth being upfront about, since Arxiv accepts a huge volume of papers across every discipline imaginable. The most detailed formal criticism came from a research team led by Wesley Andres Waters, who published a lengthy rebuttal specifically targeting the technosignature, claims built on the Palomar plates. Their argument rests on a few key points, each of which deserves a fair hearing. First, they argued that the strongest possible test of whether a transient is a real object, rather than plate damage, would involve physically examining the original glass plate under a microscope, rather than relying entirely on digitized scans. Villarreal's team, they pointed out, worked primarily from the digital versions. Second, and probably most damaging, they raised serious questions about how the sample of transients was selected and filtered. When Waters and his colleagues tried to reproduce the dataset using a more conservative, heavily vetted filtering process designed to strip out likely artifacts, their surviving sample shrank dramatically, down to a small fraction of the original 100,000 candidates. And crucially, when they reran the Earth's shadow test on this smaller, more carefully filtered dataset, the statistical dip in the shadow region weakened substantially or disappeared, undercutting one of the two central pillars of Villarreal's case. Third, they dug into the observing schedule of the Palomar telescope itself and found that, for entirely mundane administrative and logistical reasons, the observatory was simply more likely to be conducting exposures during the weeks surrounding nuclear test windows, likely tied to coordination with other government-funded research schedules of the era. If the telescope was already more active during those periods, you would expect to catch more transients purely as a byproduct of more total observing time, no alien spacecraft required. Villarreal's original analysis, they argued, had not adequately corrected for this scheduling bias. To her credit, Villarreal did not simply concede the point. She published a formal response, arguing that the heavily filtered dataset used by her critics was so aggressively cleaned that it discarded the majority of genuine transients along with the noise, leaving too small and too biased a sample to draw any reliable conclusion from either direction. She reran her own nuclear test correlation after properly accounting for the observing schedule bias that Waters had identified and reported that a smaller, but still statistically present correlation remained, an increase of around 11% rather than the original, much larger figure. Since then, the debate has continued to develop rather than settle. Independent researchers working outside either camp have taken a crack at replicating pieces of the analysis using publicly available code and data, rather than simply arguing from the sidelines. That kind of independent replication is exactly what you want to see in a controversial field, since it removes the question of whether either original team had, even unintentionally, built their assumptions into their own code. Some of that independent work has actually reported finding a similar shadow deficit and a related nuclear test correlation even after applying their own separately designed filtering methods, which is a genuinely notable result, given how hard the original critique had pushed back. At the same time, this newer, independent research has flagged other variables that nobody had fully accounted for yet, including geomagnetic storm activity, which can subtly affect the sensitivity of old photographic emulsion, and therefore how many faint transients show up on a given night, as a factor that future analysis will need to control for far more carefully before anyone can call this settled in either direction. In other words, this is not a story where one side has been cleanly and permanently debunked while the other quietly walks away vindicated. It is an active, ongoing scientific argument, playing out largely in public with credible credentialed researchers on more than one side of it, and new papers still landing as recently as this year. That is a fairly unusual state of affairs for a topic this far outside the scientific mainstream, and it is a big part of why this story has refused to go away. Even Sean Kirkpatrick, the former head of the United States government's own office tasked with formally investigating unidentified anomalous phenomena, weighed in publicly with skepticism, suggesting that solar flares or high-altitude balloon activity were more likely explanations. Notably, he offered this as a personal opinion rather than backing it with a competing formal analysis, which tells you something about just how unusual this dataset is. Even the people paid by their government to investigate these exact questions are not entirely sure what to make of it. So where does that leave us? Honestly, I think the most intellectually honest answer is that we do not yet know, and anyone who tells you with total confidence that this is definitely proof of alien spacecraft, or definitely nothing but statistical noise, is probably overselling their own certainty. What we do have is a genuinely rigorous, if contested, attempt to apply real scientific methodology to a question that has historically been stuck in the realm of anecdote. Instead of one witness in one German city describing lights fighting in the sky 500 years ago, we now have a data set of over 100,000 data points, multiple independent statistical tests, a direct physical mechanism, sunlight, reflecting off orbiting objects that makes falsifiable predictions, and an ongoing public back and forth between serious researchers trying to check each other's work. That is what science looks like when it actually works, messy disagreements and all. If even a fraction of these transients turn out to be genuine, unexplained objects that were reflecting sunlight in Earth orbit before humanity ever built a rocket capable of reaching space, the implications are hard to overstate. It would not necessarily prove alien visitation. There could be some exotic natural explanation we have not considered, some unusual population of highly reflective natural debris, for instance. But it would still mean that our historical assumption that near-Earth space was essentially empty until we started filling it ourselves in the late 1950s was simply wrong. And if it is not natural, if these really were, and perhaps still are, deliberately placed objects watching quietly from orbit decades before we even knew orbit was something you could reach, that is the kind of possibility that should genuinely change how we think about our place in the universe. We like to imagine ourselves as the newest and most curious kid on the block, looking outward for the first time, slowly working out the rules of a universe we are only just beginning to explore. It is a very different feeling entirely to consider that something older and considerably more capable than us might have already worked out those rules long ago and had been quietly looking back the whole time. There is also a simpler, more grounded possibility worth sitting with, one that does not require aliens at all but is arguably just as interesting. Maybe what Villarroel's team has actually found is evidence of some unusual natural process we do not yet understand, a rare kind of highly reflective debris, or an atmospheric effect nobody has properly cataloged before, quietly hiding in plain sight in decades of archived data simply because nobody thought to look for it in this particular way. Even that outcome would be a genuine scientific discovery, and a reminder that there are still real testable mysteries left in datasets we assumed had already given up, all their secrets. Either way, the story is not over. New papers are still being written, old plates are still being digitized, and somewhere in an archive in California, there may well be more of these strange little flashes of light waiting to be found. What do you think is really going on in those old photographic plates? Let me know your take down in the comments. I read every one of them. And if you want more deep dives like this one, breaking down the real science behind the strangest unanswered questions in space, go ahead and subscribe. It genuinely helps this channel keep making videos like this one. Thanks for watching, and I will see you in the next one.